Greetings everyone. I am Bonus Kagarama, an applied statistician specializing in data analytics and research design. I'm here to help you master data analytics using Python. If you encounter any challenges or have any questions regarding this course, please don't hesitate to reach out. I am here to support you on every step of the way. Let us embark on this exciting journey of knowledge and exploration together. Thank you. As we are still in lesson 1, basic and intermediate level data analysis, we have so far covered the 2 units: exploratory data analysis and the creation of basic tables. The third unit is the creation of basic charts. We can now open the folder named my data, whose data file is named count or area data. We open this data file. Okay. This is the data of which we need to import in a Python Jupyter notebook. Okay, now go to search engine. Search for Jupyter notebook. I explained the function of Jupyter notebook in the previous 2 units. So open Jupyter notebook. Okay. Now we go and find our folder. The folder, it is in the document. Open document. The folder is named my data. My data. Open the folder. Okay. You now go to new. Click new. Python 3. Here we are opening the new file. The new file for creation of commands and the running of results. Okay. This is our command window. Our command window. This is the new file. We can rename it here, entitled. Let us rename it and call it results. Results 3 B. Rename. For starter users, this is like the do file in starter. Do file. So we increase the number of cells. Command windows. We can now start working. Give your project the title. For instance, this is a tutorial 3. Tutorial 3 by Kagarama bonus. Title as the text, title as the text. And then, as I've been telling you for the last 2 units, before importing the data frame, we import the libraries. Import Pandas as PD. Import
Matplotlib .py plot as prt import Seaborn as SNS and import NumPy as NP. This is the Seaborn. So there are other additional libraries of which we are going to see on the way of this course. So we learn these libraries. In the first course unit, we explained the functions, the many functions of each of these libraries. Each of these libraries has got its own functions, but sometimes they are non-mutually exclusive, meaning that they can be used together due to their complementary functionalities. Okay, now after importing the libraries, we can import the data frame. We call it in an n name. Let us call it auto equal bring your library pandas dot read excel bracket and then inverted commas. So okay, within inverted commas, that's where we're going to include our path. Go to the folder called my data. Look for search for the data frame. It is called count or area data, count or area data, or double click on this data frame. We can see the path. This is the path. C colon /users /nsr /documents /my data /my count or area data. This we can write it. But here there is a slight amendment. You are going to do /, change it to slashes. Okay, go back to our command window of Excel. We run and then we execute our data frame. This is my data frame. You can see due to the big size of the data frame in terms of rows, number of rows, there are many hidden rows. Okay. There is no need of having such huge data frame. We can limit it to 2 or 3 rows. Let us limit it to 3 rows. Dot head 3 run. Okay. This is our data frame with 3 rows, meaning that the rest of rows are hidden. Okay. Exploring or examining. Let us examining the size of the data frame. Let us examine the size of the data frame. Call your name of the data frame dot shape. So this is the command we use to see the size of the data frame. Run it. You can see this is 175 rows. My data frame has got or contains 175 rows and 60 columns or variables. Let us go on. Now, basic charts. Basic charts or creation of basic charts. Sorry. Creation of basic charts. Okay. Univariate analysis. Univariate analysis. Pie chart. Univariate analysis. Pie chart. What is univariate analysis? This is the analysis carried out on only one variable. For instance, we are going to see the percentage of the population, by urban rural, or the percentage of the population by urban rural. Bring your data frame within a square bracket. You include the inverted commas and bring your variable of interest. Urban rural, this is area. Area dot value counts dot plotting what kind of chart and then include the percentage out of percent equal inverted comma percentage sign 1.2, meaning that we are going to report in 2 decimal places, comma. You also include the size of the figure size equal, for instance, 4. Let us run it. Unmatched. There is another bracket lacking here. Run. So this is our pie chart. This pie chart is incomplete. it is lacking the title. Let us include the title. In your Matplotlib, your Matplotlib library dot title the percentage of urban and rural. As simple as that. And then we run. You can see now our pie chart has got the title. So to omit this rubbish we see here, let us include plot.show this command. We also include this command. So you can see there is no longer rubbish above here. This is the univariate analysis. The percentage of maize, the percentage of urban and rural. 55% reside in rural areas and 45% reside in urban areas. That is univariate analysis. Increase the number of cells two-way now. Let's say two variable analysis. Two variable analysis. Two variable analysis here. So, what is two variable analysis? Two variable analysis is carried out on two variables at a go. This is the analysis carried out on two variables at a go. They can be represented as a table or chart. So now we still need pie chart. Pie chart. We are going to see the proportion of males and females by age. Or we are going to see, here, for instance, we know we don't have ages, but we can have marital status. The proportion of males and females by marital status. The percentage or proportion of males and females by marital status. And females, these are the value labels of sex. Here, bring your Pandas library dot cross tab in the bracket, bring your data frame and within square bracket, bring your variable, first variable, which is sex, comma, and then bring again the data frame, and within the square bracket, you include the second variable, which is the marital status, proportion of urban, rural by marital status. Comma, this dot plot kind equal I. We need the pie chart for two variables, and then include the percentage, auto percent equal percentage sign 1, report it to 2 decimal places, comma, subclass equal true, and also include the size of the figure. Let's say 15. Run. Module Pandas has no attribute cross turn. It is not a cross turn. Instead, it is a cross tab. Run. Okay. Just say plot.show to omit this rubbish here. Plot.show. Fine. Let us increase the size from 15 to 16. Run. And see. 85% of females are divorced, whereas only 15% of males are divorced. 80% of males are single, whereas only 12% of females are single. So you interpret each of these pie charts in that. Let us find another alternative. We copy again the above command, and you exchange the variables. Where there is sex, we include the marital status. Where there is marital status, sex. Just exchange the variables, and we see another option of the figure, sex. Run. This is another option. Okay? Just exchange the variables. These two figures can be interpreted in two ways. One way of interpreting is by interpreting each figure independently. And the second way is by comparing the two groups. Females, this is for females, and this is for males. Okay. Independently. 80% okay, let's start with this, with the biggest one. 80% of married people are females, or 80% of females are married, whereas only 70% of females are single and widowed. Again here, 39%, let's say, here, we started from the biggest, 80% of males are single, while only 70% of males are married and divorced. Okay. Independent interpretation independently. Now, by comparing the two groups, .3% of females are married, whereas only 70% of males are married. 80% of females are divorced, whereas only 70% of males are divorced. So that's those are two ways you can interpret the such kind of pie chart, 2 by 2 or 2 variable pie chart. Okay. Univariate analysis. Univariate analysis bar charts. Okay. We want to run the percentage of males and females bar chart. Using bar chart, using the bar chart, run the percentage of males and females. Okay, we create the new variable equal, bring your data frame, and within square bracket, bring your variable of interest dot value counts dot plot within the bracket. What kind of plot is bar chart, comma, we also include rotation, let's say 60, and then color, include also the color of the chart. Let's say maroon, width. What is the width of your bar chart? Let's say 0.8, and then include the size of the figure. Size of the figure equal, let's say 7, 3. We run. Name df is not defined. So this is the name of our data frame is auto, not df. Run. Labeling the bar chart. Because this bar chart is not complete. It is lacking the title. It is also lacking the variable, which is sex. Here you can see only the value labels, male and female. Yeah, and it is also lacking the y-axis label. Okay, let us start with the title. Bring your library, your PRT, your library t dot title the percentage of males and females. If we run, we can see the title. Let us also name the x-axis label. Plot dot x label sex, or let's say gender. You can see we have included the variable for male and female gender. On the y-axis, let us call it counts. For instance, counts. plot.y label counts. Run. So we have labeled our data, our bar chart. So what is lacking here? Labels. Now, adding labels. What is lacking is the value labels. Adding value labels. Value labels in terms of counts. The command here for container in AEX, the new created variable for our command. The container, these are containers in AEX colon in AEX dot containers comma, colons, ax being your new created variable dot bar label. You are now labeling your bar chart in bracket container. You can see now we have labeled our bar chart. So this is 88, 87. 88 are males, 87 females. So you can see the limit of the line here. The line is the y-axis line, horizontal line here, is hiding a bit our labels. So let us increase the y-axis, the limit of y-axis. Our plot dot y limit comma and the square, no, open the brackets and the square brackets. 0, it is starting from 0. The limit is starting from 0 to 80. 0 to 80. Let us have the limit of 0 to 90, for instance. Run. Oh, still hiding. 0 to 100. Run. Okay, you can see now our limit has increased. Here we can clearly see our value labels. We can see how wide our bar charts are. We can reduce the size of the width. As I told you, the first digit is for adjusting the size of the width. Second digit is for adjusting the height, the size of the head. So let us reduce the width to 5, for instance. Run. We can see how it looks. 4, the width to 3, and the height to 2. Run. That's how it looks. So now, our bar chart is complete. This is the percentage. Now, this is the frequency. So, frequency, let us make it as a frequency. The title, this title is copied down here. Change frequencies to percentages, because this is the frequency or counts. Run the frequency or counts of males and females. Now, in terms of percentages, learn the percentages of males and females. In terms of percentages, we copy the same command, this command down here. And then AX equal to auto square brackets sex dot value counts within this bracket. You can say normalized equal true. got an unexpected keyword argument normalized. Normalized, you just say normalize. Normalize, okay. In terms of percentages, so this is no longer in terms of counts. If you say 0 to 100, it is in terms of percentages. 0 to, let's say 0, 0.9. 0 to 90%. Run. So you can see now. We can see. So 50.3% males, 49.7% females. So you can see this, there is a huge limit here. We can reduce it. T.y limit 0. So the maximum value is 50.3%. So let us reduce this limit to 60%. Okay, you can see now how the bar chart looks like. We can also name this. This is no longer counts, instead percentages. Y label percentages. Or I say the percentage sign. As simple as that. Okay, two variable analysis. Two variable analysis is the analysis carried out on two variables at a go. Every time we need to create a command, we better bring the data frame in order to clearly see your variables you're going to use. Marital status. Marital status by sex or by gender. Or say sex. Bar chart. This is a bar. We need a bar chart. Total equal, bring your data frame, your square brackets, and your variable of interest. You need it to appear as a column. Dot count. Dot count. This is getting this is getting the total count or the type column. For P in AX dot patches column labels, labeling now, equal your inverted commas and create the data dictionary for the column, or for the all columns of data values reported in one decimal place. Dot format 100 times p dot get height divide by total x equal to p dot get x plus p dot get width and y equal to p dot get height ax dot annotate. We're now going to add the value labels in bracket x, y, manipulate the variables. Let us run and see. You can see our bar chart, how it looks like. This is the female and this is for male. Divorced, married, single, and widowed. Divorced, married, single, widowed. Positioning, let's say, left. If it is left, how does it look like? No, let's say right. Yeah, fine. So the height is big. Let us reduce the height from 5 to 2, for instance. Run. So reduce the height. Here, as you see, the value labels here for single on females and for married on females and single on males. The value labels are at the limit. So let us increase the y-axis limit. Y-axis limit. Let's come here, add plot dot y limit as you can see, the maximum value is 24. It is 24, here it is 40 on the y-axis. Let us make it 45. 0 to 45. 0 to 45. There was a 0 to 44, now it is 0 to 45. Now 0 to 50. Okay, great. You can see your value labels are clearly seen. So you can also copy We can also exchange the variables and see the different figure, and have the different figure. Copy the same command down here. Just exchange the variables. Where there is a sex, put marital status. Where there is marital status, sex. Let's change the variables. Sex. And run. Just to see how it looks. But our bar chart is lacking. Okay. Is lacking the title and the y-axis label. Let us increase the height. Let us increase the height here. The height 2 to 3. See how it looks like. Okay, fine. From 2 to 3.5. From 3 to 3.5 height. This is the width. The width is okay. Run. Let us see. Okay. This is okay. We are going to give the title, to write the title of the bar chart. Being plt library dot title percentage of males and females by marital status, or marital status by gender. Just say marital status by gender. Run. You can see this is the title of the bar graph. Reported in percentages. Let us label the y-axis percentages. Add, yeah. Plt dot label y dot label plt dot y label percentage. Run. You can see percentages. Percentages. What else is lacking here? Now our bar chart is complete. So you can see it is reported in one decimal place. So if it is in 2 decimal places, we can just add here 0.2 instead of 0.1 and then run. You can see 2 decimal places. That is the 2 variable analysis bar chart. Let us reduce the width from 11 to 9. I see. To 9. Run. Yeah, you can see the width reduced. From 9 to reduce still the width from 9 to 7 and see. You can see how it looks like. So the rotation for our x-axis labels. If it is 50, it looks like this. Rotation, if it is, for instance, 30, it looks like this. If it is instance 70, looks like this. Let us increase the width of our bar chart from 7 to 11. Okay, this is how we create the charts. The next course unit will be creating the dependent bar charts, charts that are dependent on the table. Okay, thank you. If you are interested, please subscribe, like, and share, and we'll meet for the next course unit.